Hello everyone, my name is Manoj Ayyappan and I, along with my teammates Sanket, Kunal and Shreyas, have taken part in the IBM Hack Challenge 2020 with a team named Codeplay, and the domain that we have chosen is Twitter sentiment analysis. So the problem statement that we chose is to develop a dashboard with the visualization of people's reaction to the government announcements, and to do this we have to use the relevant hashtags on Twitter and build a predictive analysis model. So we divided the project into four stages: data collection, pre-processing, modeling and plotting, and UI and deployment. I will be talking about the data collection part. So we start by importing the essential libraries like getOldTweets 3, CSV, and TextBlob. The primary reason that we use getOldTweets 3 is because we wanted to get tweets which are older than a week, and this was a limitation using TweetPy, that is the actual API of Twitter. Getting the tweets using query search, we used three or four attributes like we can set the start date and the end date, and also the language and the number of tweets that we want to have. In the second one, we also added two more attributes like set near and set within, which lets us specify the location from which we want to get the tweets. So the last part is to write all of this data into a CSV file using these headers like tweets and polarity. So we got the value of polarity using the waiter library. And we also used a function called .correct, which will be explained by my teammate Shreyas.
So the next step after data collection is the data pre-processing. Data pre-processing is the process of converting data into something that the computer can understand. The NLTK library helps us to perform simple language processing. The RE library helps us to deal with the regular expressions, and the TextBlob library provides us a simple API to perform simple NLP tasks such as sentiment analysis, classification, translation, and many more. The first step under data processing is data cleaning. Data cleaning is the process of removing unwanted data from our dataset, which would decrease the accuracy of our model. So since we have used tweets as the main data for our dataset, it consisted of a lot of spelling mistakes. So to correct this, we have used the .correct attribute of TextBlock. While executing our program, we observed that the .correct attribute took a lot of processing time. So to minimize this, we have made an alteration and executed the .correct method while the data collection process, so that the final dataset that we obtain is already rid of spelling mistakes. So after we get our dataset, we have to remove the stop words. Stop words are the most commonly used words such as a, and, the, etc., which do not contribute towards the sentiment of a sentence and take up unnecessary processing time. As you can see, we have made an exception for the word not, so as to include negative phrases in our result as well. So the first line under the for loop, we have removed all the punctuations from the sentence as we require only words in our final output. In the next step, we have converted all the sentences into lowercase, and in the next line we have split the sentences into words. Lastly, we have appended the words which are present in the review variable, which are not part of the stop words, into our empty list corpus. So the end result that we obtain from the corpus is called a bag of words, which contains the words present in our dataset excluding the stop words. The next step will be explained by Sanket.
So the next step after data cleaning is the data modeling or analysis. So this process consists of four steps. The first step is measuring the polarity of the tweets. So this is achieved by using the Vader library of Python. So why Vader? Because Vader is a sentiment analysis tool that is specifically attuned or specifically responsive to the sentiments expressed in the social media. So it means that it can analyze the sentiment in the social media text easily. So we have included this code in the data collection file itself in order to lower the processing time. So we have created an object of the Vader sentiment analyzer and then appended the review of the particular tweet into the dataset. The next step is to analyze the sentiment counts. So we have set a criteria for the positive, negative and neutral tweets. So for example, if the polarity of the tweet is greater than 0.05, we consider that positive tweet. If it is between 0.05 and minus 0.05, we consider the neutral tweet, and if it is less than -0.05, we consider it as a negative tweet. So thus we have the total counts of sentiments. Then the next step is to analyze the emotions in our text. So we have the clean data loaded into the corpus, which is a Python list. So we have our own data set, which is the emotion.csv, which contain two columns, the word and its respective emotion. So we search for the word into the corpus and append the respective emotion into the emotion list. So we then finally count the number of emotions present in our list, and then we using the counter library. So this counter library converts this into a dictionary which contains the emotion and the counts. The next step is to plot or visualize the data, which is done with the help of matplotlib library. So this library contains pyplot function which helps to visualize the data into pie charts and bar graphs. So we have the pie charts for polarity and the bar graph for emotions. So as we can see, we have the percentage of the positive, negative or neutral tweets present in our pie chart and the tweet count of the emotions present in a bar graph. So this is all about the data modeling analysis. The next part of UI will be explained by my teammate Kunal.
Displaying the output of our model in a user-friendly way was one of our biggest priorities. To achieve this, we developed a website using Node-RED and IBM Cloud Services. The first and introductory tab of our website is the home page. This tab is primarily developed using the template node using the HTML and CSS languages. The COVID tweets analysis and lockdown tweets analysis tabs are the tabs which display the output of a machine learning model. This was achieved using the function node and the chart nodes. The function node provides the data that is to be displayed which we obtained from the model. The chart nodes provide us the visual representation. As you can see, hovering over the pie chart and the bar graph gives us the information of that particular element. The lockdown tweet analysis tabs works in the similar format as its previous counterpart. In this way, the user can get a detailed analysis of the public emotion regarding both the COVID virus and the government imposed lockdown. One of the most interesting tabs of our website is the live tweet analysis. The Twitter node extracts the latest tweet tweeted regarding the ongoing pandemic. The extraction rate is 1.1 tweet per 3 seconds. This tweet is then analyzed in the sentiment node. The gauge displays the polarity of the latest tweet. The user can study the line chart to compare the polarity of the latest tweet with the previous ones. Another interesting tab is the Check Your Own Sentiment tab. In this tab, the user types a text which is extracted by the text node. This text is then processed in the sentiment node. As the words COVID, Corona are basically scientific terms, they couldn't be processed by the sentiment analyzer. To solve this problem, a series of switch nodes were used which provide the polarity for those words themselves. When the user enters his text, the intensity of the text is displayed in the gauge on the right. The polarity of the text is shown in the text box as well as in audio format. The last part includes the COVID India tracker. The HTTPS request tab extracts the data from the api.covid19api.com website. This data is extracted daily using the ShedX nodes, which run themselves automatically each new day. The data is stored in the Cloudant database. A series of functions, ShedX and Cloudant nodes help to update the data. As you can see, the most recent data of active, recovered and total cases as well as deaths is displayed in the numerical and pie chart format.